Secondary storage. So if you have your processor here and then you have RAM, okay, we know that the processor reads information directly from RAM. If the electricity were to go out, if you recall, anything in RAM is gone. Therefore, we need to have a secondary storage device. Okay, for instance, in this picture here, this is a hard drive. A typical hard drive in a desktop computer. If you open up the hard drive case cover, this is what you'll see. Anything stored here is retained if the power goes out. There are several important characteristics of our secondary storage device, such as a hard drive. These characteristics are, number one, media. Media is a physical material that holds the data and programs. Capacity, which measures how much a particular storage medium can hold. The actual storage devices, which are the hardware that actually reads data and programs from the media. And then of course there's the access speed, which measures the amount of time required by the storage device to retrieve data and programs. Next, let's actually talk about a hard disk. There are two types. The very first is our internal hard disk. This is what we'll find in our desktop or laptop. And then second, we have an external hard disk. Here you have a laptop connected by an external hard disk, which if you open it up will have platters just like this, but it's outside of the system unit of your desktop. It's kind of like an addendum to store data. Now if we look at this picture here, we have another picture which represents the actual picture, showing logically how things are managed. Here we have platters. So with platters, that's this thing here, and each platter, all right, has tracks. So here's our track here, and it goes around in this contiguous manner because your actuator and reader here will read this disk as it's spinning and read the data off the magnetic particles, which will have a charge or no charge, so to say, which gives us our ones and zeros, all right, off of the platter. And each of these tracks, if you divide it into pies, have sectors within them. There's also another term known as a cylinder, and that runs through each of the tracks. In other words, because you can have more than one platter, you want to know which track and which sector on which platter you need that information from. Our next term here is a head crash, and that happens because of, there's a better picture, when this is spinning, the distance between this needle here and the platter is not much of a distance. Specifically, it is approximately 0.00001 inch thick. 0.0234, I believe, inch thick. And anything from like a smoke particle or dust can actually get in between there, and thus causing physical contact with the disk and thus creating what's known as a head crash. In other words, loss of data. Here's another term called disk caching. With disk caching, it kind of works like when we had cache up here, cache 1, cache 2, and then maybe cache 3. And what happens here is that frequently used data is identified and read from the hard disk into the disk cache. And when needed, that data is then accessed directly from memory. So in other words, it's just like cache up here, except now we're having cache on our storage device to basically speed up access time. When we're dealing with hard drives, we can also have what's called RAID, a redundant array of independent disk. And what this does is it just simply provides data. Picture these each as hard drives, and you're spreading your data out so that number one, you can access it easier because there's less contention, so to say, and that you can. This could actually be all the same data as well, thus creating a redundancy in case one of these disks were to crash. So again, the important things here is here's our platter. Each of these things are tracks. Each of these, once you cut it up into pie sections, each of these little pie sections in themselves, these little wedge-shaped sections, are called sectors. So we talked about hard disk, and these are, as you can see here, they're moving parts. There's actually spins. All right. Now we have what's known as solid state storage. Solid state storage. And there's no moving parts in these particular drives here. All right. This is actually a picture of a solid state drive in a laptop. Okay. These solid state drives, all right, provide access and storage through something known as flash memory. If you were to turn off the electricity on here, everything would still be stored. It's secondary storage. Solid state drives do access information faster than these drives up here with platters, and they're actually more durable. They require less power. However, they are more expensive. In this picture here, we see what's known as a flash memory card, okay, or basically a flash memory card. Here it looks like it's for a camera, okay. Another use for a flash memory card, if you're downloading music and you're afraid of using too much of your airtime, okay, when you're playing music, you can download it onto your smartphone, and smartphone's flash memory card, in other words. Since your smartphone may have limited space on its solid state drive, you can also increase it by using a flash memory card. And then of course most of us are somewhat familiar with USB drives, since there may be times you want to carry it with you for redundancy. Why? Because you may not have access to your hard drive in the clouds, and thus you want to be sure that you have a backup copy of it on a flash drive. Another secondary storage device is what's known as an optical disk. Optical disk can provide storage up to 100 or greater than 128 gigabytes. Before solid state storage devices became more affordable, optical disks were used heavily in terms of storing information as backup and software information as well. And how does it work? Optical disks use what are known as lands and pits to represent data. So you can have a pit, and then you can have a land on your optical disk as you're reading it and it's spinning. And as light shines down on it, it could be absorbed or it could be bouncing back as light is shining on it. And that will represent either ones or zeros. From my recollection, if it bounces back, it's a positive one, and if it's absorbed, it's a zero. There's several types of optical disc. You have your CDs, your DVDs, and your Blu-rays. Okay, and out of those, they can be read-only, which means you can only read data off of it. You can only perhaps write only once to it, and then once you write once to it, that's all you can do, even if you only use a portion of the disk. Or it could be read-writable, where you can read to it, where you can write to it. Okay, read it, write to it again, read it, etc. Next, we have what's known as cloud storage. When servers on the internet supply applications as a service rather than a product, all right, this is basically cloud computing. Okay, you have a server up here and you're down over here with your laptop and you're getting access to, like in this case, the picture looks like, oh, there we go, Google Docs. All right, so the Google server here, which is all in a part of the internet. Okay, it's providing a service to us, giving us access to Google Docs, a Word document, a presentation document, etc., and thus providing cloud computing services to us. In addition to storage outside of the documents that they're giving us, we can store those documents up here up in the clouds. What are some of the advantages of storing it up in the clouds? Well, the very first is maintenance. All right. Is there anything you need to maintenance on your laptop? Yes, you need to defrag it sometimes. You need to back it up in case it crashes. Well, here's the great thing here. If all your information is up here in the clouds on a server that Google's maintaining, they're doing it for you. They're handling the hardware upgrades for their server. All right. And it makes it easy for them to provide other cloud computing services such as file sharing and collaboration if you ever wanted to work on things together. So if you wanted to work on things with your classmates, you can use a Google Doc for Word or their presentation software, and then easily share it with other members so that they can update it and share the changes with you. What are some of the disadvantages? Well, your access speed will be determined how fast you can access these documents. will be determined by your internet speed. And of course, security. Their way of securing the data up here in the clouds may not be as secure as your own way of securing data that you're working on. And last, we have what's known as a mass storage device or mass storage devices. Within an enterprise storage system, okay, in other words, every organization is going to have some type of enterprise storage system. You'll have several components, several components that are categorized as mass storage devices. The first is going to be your file servers, where you can basically store a plethora of things because they serve and store your files. The next is what's known as an NAS, which is an acronym for a network attached storage device, where you can easily this is actually a picture of one, attach it to any network that you want to do that in. They act kind of like a file server, but they're really easy and quick to do. They're popular at home, where you can perhaps attach it to a department that's running somewhat independently. In your storage system, you may also employ a RAID system, or an array of redundant independent disk, and we've talked about that earlier over here. Okay. You can also have what's known as an organizational cloud storage, where you have a high-speed internet connection to a dedicated remote storage facility somewhere in perhaps another country. Okay. And then your enterprise storage system can employ a storage area network. All right. A storage area network is an architecture to link remote computer storage devices, such as an enterprise storage systems, to computers such that the devices are as available as locally attached drives. The key to a SAN network is having a high-speed network connecting individual computers to mass storage devices, where you have special file systems preventing simultaneous users, from having conflict with each other. So in a nutshell, today we talked about secondary storage. As you can see in this picture here, and you can read it in your text about the future of where you can actually store these ones and zeros, not just in material that we see today as non-organic, but also in organic material. Interesting. But what we talked about today were, number one, the characteristics of secondary storage device in terms of the media that we use, its capacity, all right, how much, in other words, the actual devices used to store the media, and how fast we can access it. To the hard disk, whether internal or external, and the commonalities between internal and external in terms of its characteristics. Going from a moving device to a device that's solid state, not moving. All right. From flash to USB drives, or flash cards to USB drives. And then the optical disk, where we read a disk and look for a land or a pit that tells us whether it's ones or zeros. The cloud storage, rather than storing locally here on our own laptop, we're storing up in the clouds. 2, mass storage devices and the components we would use in an enterprise storage system. And that's it for Chapter 7.